So, what do you get when you combine some backyard junk, a regular old firecracker, and a little bit of physics? Well, you get a rocket. Today, we're diving into a project that proves you don't need a billion-dollar budget to reach for the sky. Turns out, all you really need is a whole lot of ingenuity.
At first glance, this sounds like a weekend project for a kid, right? But the question is actually a pretty serious one for engineers. Can you create stable, predictable flight using basically nothing more than household scraps? It's a challenge that really strips rocketry down to its bare essentials, and one project decided to take that challenge head on.
And that project was called Project PAWAN. Its mission was simple, but, pretty ambitious. Prove that you can build a stable, functional rocket, not just on a low budget, but on a zero budget. This was never about making a toy. It was about laying the scientific groundwork for something much, much bigger.
So, yeah, forget just seeing if it would launch. The real aim here was to gather data. Could it fly straight? Could it handle the stress of launch? Every single observation was a data point, a critical piece of the puzzle that would serve as the foundation for more advanced designs down the road.
So how in the world do you build a rocket with no budget? Well, you raid the recycling bin. Let's take a look at the anatomy of this surprisingly clever little vehicle.
Just look at this parts list. It's all about finding the right material for the job with whatever you've got lying around. The body, for instance, needs to be light but rigid. So thick cardboard? Perfect! The fins need to provide stability, and a simple 3-fin setup made from more cardboard is actually enough to do the trick. And for propulsion, a standard firecracker motor. It provides just enough kick to get this super lightweight frame off the ground. This is resourcefulness in action, right here.
But see, using simple materials means your design has to be smart. Every choice here follows a core rocketry principle. The body is shaped to be aerodynamic, letting it slice through the air with as little resistance as possible. It's incredibly lightweight, so that tiny firecracker motor actually has enough power to lift it. And the motor? It's perfectly centered, making sure all that push goes straight up, not off to the side.
Okay, so we have the parts and we have the design, but how does a bundle of cardboard and a firecracker actually defy gravity? Well, that all comes down to some really fundamental physics. It all boils down to this one simple rule: Newton's third law of motion. You've heard it a million times. For every action, there is an equal and opposite reaction. I mean, think about it. If you blow up a balloon and just let it go, the air rushes out one way and the balloon zips off in the opposite direction. That is the exact same principle that powers everything from this little rocket to the massive ones launching satellites into orbit.
So here's how that law plays out. Step 1, ignition. The firecracker motor lights up. Step 2, gas expulsion. That's the action. Hot gases get blasted downwards at super high speed. Step 3, thrust. And that is the opposite reaction. The rocket gets pushed upwards. And finally, as it's climbing, those little cardboard fins act like the feathers on an arrow, keeping it stable and flying straight.
With all the theory in place and the rocket sitting on the pad, there was only one thing left to do. It was time for the moment of truth.
This is that moment every engineer, every creator just holds their breath for. All the planning, all the theory. It means absolutely nothing if it doesn't work in the real world. So, after all that, did it actually fly?
Yep, a complete success. The little cardboard rocket totally defied gravity and took to the sky. A huge moment for the project. And it wasn't just that it flew, it's how it flew. The liftoff was strong and the flight path was perfectly straight. There was no tumbling, no wobbling, which is absolutely crucial. It proves the design was balanced, the fins were stable, and all those core principles were sound. Everything worked exactly as planned.
But the real value of a first flight isn't just the success itself. It's the data you get from it. This test proved that fin alignment has to be perfect for stability. It showed the cardboard body was surprisingly strong. And it confirmed that the thrust-to-weight ratio was right on the money. This wasn't just a launch. It was a treasure trove of information for whatever came next.
Because a successful proof of concept is never the end goal. It's just the beginning. So where does a project like this go from here? Well, the plan is to take everything that was learned and build something far more powerful.
This quote really puts the whole thing in perfect perspective. Project PAWAN was never meant to be the main event. It was the booster, that essential first stage, designed to provide the initial push for something with far, far greater potential.
And this just shows you how big that next step really is. The project is evolving from a simple proof of concept into a fully engineered launch vehicle. We're talking about going from a single stage to 2 stages, from cardboard fins to durable plastic, and from a simple body to a reinforced one. This is a complete and total overhaul.
And that right there is the key takeaway for the next phase. The Mk2 isn't just an upgrade, it's a leap in complexity. It means moving from simple assembly to genuine engineering, tackling bigger challenges like multi-stage separation and more powerful propulsion systems. It's really the difference between a model and a machine.
This single sentence just captures the entire spirit of the project, doesn't it? It's this powerful reminder that the most incredible journeys often start with the simplest materials. It proves that with ingenuity, curiosity, and a bit of ambition, you really can aim for the sky, even if you're starting with nothing but cardboard.